more practice this morning or today, I guess, if you're not watching this in the morning, with finding feasible regions and graphing. So I'm going to start with this one. X is less than -2. That's an up and down line at -2. And it should be dotted, right, because of this. And then I'm going to ask myself, what are all the numbers less than -2? Those would be here to the left. And then I have y greater than 4. I'll do that one in purple. It's greater than or equal to, so I'm going to use a solid line. +4 is up here. And then I want all numbers greater than, so that would be these. And my feasible region, if you remember from yesterday, is just the spot where they overlap. Okay, so it's just going to be this part in gray. I'm going to erase my other stuff. The only thing I want shaded is my feasible region. And then I need to find the vertex. And this one's not too bad. My x value is -2, and my y value is 4. So when you know your x and y, that one's pretty simple. This is your feasible region for this one. Okay, it wasn't too bad. Let's try another one, a little tougher. I'll do this one. I'll use purple again. 7 minus 2/3 x. I'm going to use a dotted line because of the greater than symbol. My y-intercept is 7, so I'm going to put a dot at 7. Then I'm going to go, my slope is -2/3, so down 2, 2 over 1, 2, 3. Down 2 over 1, 2, 3. And again, this one is dotted. Okay. Then I'm going to test 0, 0. And then I'd have 0 greater than 7, and that's false. Okay, so I would shade above. Oh, I want to use purple here. All right, for my next one, I like to do x and y intercept. Okay, I'm going to use a solid line here. So if I plug in 0, it looks like I get -6. And if I plug in 0 for y, I get 4. So over 0 down 6 and 4. And then this one's a straight line. Okay, and I'm going to test 0, 0. So I get 0 less than or equal to 12 when I do that, and that's true. So that's good. So I'm going to shade this area. Okay, and for my feasible region, I only want the overlap. So it looks like that's this part. So yesterday, when I did this, I thought that the vertex was super easy to find on the graph, but today it's not. So instead of looking at our graph and just trying to guess, I'm going to use, and for this one, I'm going to use substitution. Okay, so we learned 3 methods. Graphing isn't always the easiest. I'm going to use substitution because I already have something as y equals. Okay, so hopefully I have enough room here. So I'm going to go 3x minus 2, and y is 7 minus 2/3 x. And when we do substitution and elimination, we pretend it's an equal sign. Okay, it's a little hard to do it with that inequality sign, so we're going to just kind of substitute in that equal sign as well so that we can figure out what our x and y equal. 4/3 x equals 12. Oh, this is rough. 4/3, and so I think that I'm going to have, and you guys could verify this on your calculator, I think I'm going to have 4 and 1/3 x minus 14 equals 12. I'm going to switch this to a mixed, what is it, an improper fraction. Okay, and you can do the same. I checked that all of these were whole numbers, so now I'm really hoping that all of these are whole numbers. I'm going to add 14 to both sides. And I have 13/3 x equals 26. I'm going to multiply, oh good, 3 over 13, and I get x equals, And I would love for you guys to verify this x equals 6. And that looks right. My graph is a little off, but it's pretty darn close, right? So 6 comma, and to find the other part, remember I'm going to plug it back in. I'm going to plug it back in into the y equals, remember I'm calling it equals 2/3 times 6. Okay, so I'm just doing that idea of substitution for y equals 3. Okay, and again, my graph is a little off. It's not perfect, which is why I can verify using substitution or elimination. So my vertex is at 6, comma 3. Remember to go back and pause it. Okay, I made a mistake last time, but I figured it out, and so I'm ready to graph this again. -1, -8 is down here, and then I can go up 2 and over 1, and up 2 and over 1. And then when I test 0, 0, I get 8 is greater than 2, which is true. So I'm going to shade up here. Okay, then I'm going to graph this one up at +4, and then go down 3 over 1, down 3 over 1, and then I'm going to, this one should be solid, graph this line. And when I test 0, 0, I have 0 less than or equal to 4, which is true. So I'm going to shade on the side of 0, 0. So it looks like my feasible region then is this in here. I'm going to erase my pink and purple here. To find my vertex, I'm going to use substitution. So I'm going to plug it in and say, I'm going to plug this y in right here. -3x plus 4 plus 8 equals, remember I use an equals when I do this. I can combine like terms on this side, and then I'm going to distribute. I'm going to get all the numbers on one side and all the letters on the other. So I have 10 equals 5x divided by 5. And I have x equals 2. That looks about right. You can see my line is not perfect. And then for the other one, I plug this in. Let's plug it into y equals -3 times 2 plus 4. Y equals -6 plus 4. Y equals -2. So my vertex is +2, -2. You can see that because my graph wasn't perfect, it was really great to check with substitution.